Welcome everyone to another open source Linux and stuff live stream. And one thing you recurring subscribers know I have is this overkill Ryzen build 1550X. Previous videos there on the more main channel. Asus Pro workstation board and Derbauer offset plates and Kraken and ZXT. Whatever, something AIO liquid cooler. And so one thing that is still, that annoys me, like, yeah, first, well, you need this Python stuff, and I'm not sure in the meantime it's still experimental. We packaged that previously, of course, liquidctl. So if you just run that stock, then it has some whatever default fan stuff that cools nothing. So you basically need to run something, right? Either the, God forbid, the NZXT totally garbage and Electron-based chem or so. Windows software, like even cloud login, because obviously you need to freaking cloud login NZXT for your bloody Windows fan control stuff. But anyway, obviously we're not using that. But so what? I could use it, of course. I've run liquidctl. I mostly, well, I also acted a little bit for the bloody display. I also theoretically need to still finish the auxiliary display stuff. But somehow every now and then I checked, somehow I still have not found an amazing way to control that better than this like fixed value. So how you control that here is, maybe also liquid set pump fan speed here. This is degree in sane units, aka Celsius, centigrade. And so like 26 degree, 10%. So this is, so the problem, so this works somewhat, but even that, given my ambient temperature, we don't have usually air cons in most of Europe, not like in the States or elsewhere. So I have vastly varying temperatures, right? In the winter here in this office, I have like maybe 18 or even 17 because cheapskate and stuff. And in the summer, some days it's approaching 30 degrees, right? To the last days we had nearly 30 degrees. It's global warming and stuff. Summer is coming. And so this totally doesn't scale. So what is the issue is that with this fixed curves, this is of course, sure, it works in winter, but in summer it's like, yeah, so if you don't tweak that, the whole day the fan is running with 100% basically, because I know it's obviously 30 degrees in the freaking office. Cheers. And so what I would expect is to wire this to the CPU speed for the most part, or also CPU temperature. But with this AIO or liquid cooling, it's a little bit tricky, right? I'm not sure if, well, except you watch those big million subscriber YouTubers that constantly drop their stuff there with their tech tips, and roll over with the office chair on your precious Intel CPUs. But kidding aside, neither wiring that to the CPU temperature, because the CPU temperature jumps quickly, right? So if I start a compiler, so let's not waste time, we have theoretically some stuff to do. I notice there's Firefox 100.02, I think. And so the problem is, in the Windows software, this God forbidden cloud login, is it NZXT chem or whatever, you can control, wire that to the CPU load and stuff, or some temperature. That's CPU load, maybe CPU. Anyway, so the problem with the CPU temperature is that it rises so quickly, right? And even with, like, if I epic thread rip here some Firefox, then we have 70, I think, degrees quickly. And even with 100%, I wouldn't instantly want 100% fan, because obviously the whole liquid system takes some time to warm up. And so what I would want is the pump. I would even wire the pump, because we have two controls here, the pump and the fan. I think instead of the temperature, because, I mean, although I could check how fast the temperature rises, but maybe it would be even better to wire the pump to the CPU load, so that if you have CPU load, your pump immediately goes like to 100%, especially on this epic thread ripping systems here, to cool the CPU and optimize your boost before your CPU even overheats, right? Otherwise, if you wire it straight to the temperature, then your CPU gets warm and throttles before even your pump starts to circulate the liquid there. Just some thoughts, right? So I'm not sure. I googled that every other day. I check here this. I even checked here today this liquid control. If in the latest version I don't immediately see something, if there's something to wire that to some temperature, I only see here what I do. He said send speed. Here also, yeah, all this, so the default stuff totally doesn't scale, right? It's suboptimal. Also, yeah, I mean, this example already, the pump speed 70. I wouldn't want the pump always on 70%. And I think, in my thinking of binding the pump speed to the CPU load, at least somewhat, maybe using two input signals there, the CPU load and the temperature, and combine those somewhat. Certainly need some experimentation, because I think the pump could even go down somewhat. Certainly not. This is why you would want to combine that, I guess, and maybe make the CPU load rise that, and then if the CPU load is low, or I don't know, or like trigger CPU load. If CPU load goes up, immediately raise it, and then with some threshold let it go down based on the temperature. Because if the CPU is idle, then again, like let's say we compile Firefox now, because obviously we want the latest Firefox, which will epic thread rip for. Will it even build in? Maybe we should switch to that tag and all right, we renamed this obviously. Smart pens here. Yeah, this fully doesn't matter. So if we epic thread rip through that, even in the end we will have a very long, I think like even 3 or 4 minutes or so, if not 5 minutes of quite single core link time optimizing bottleneck. And during that, probably the CPU load as a pump could go down quite a bit, like maybe some base circulation stuff of 50%. Also, why would we do that? To save the pump from wearing out, right? I don't like, sure, I could do that, and I see some YouTubers of like, yeah, this AIO stuff is shit and it falls apart and stuff, and warranty not amazing. I've only sample size 1, so far this stuff is so good, but to improve longevity of the stuff, maybe scale the pump down faster and still let the pumps, the fan, still cool down the liquid there until the liquid system reaches some kind of ambient temperature again. Can we probably, let's maybe try to build this with the problem is, or let's make it easy, because I just renamed it yesterday. I did not rebuild that. And let's try to build Firefox. Those are just some thoughts, right? I mostly wonder that, as per usual, I do so much stuff here, and then it's like the few things I would eventually want to have, and you wait like for probably, do I have this already a year, or at least half a year? Not sure. I have this for quite a while. So why does this not play anymore? All right, we probably are done. Right, I think there was something. Let's selectively switch that to, what is it? But no, finally. So just some thoughts. Leave them in the comments below. Correct me if I'm wrong. And definitely, if you have any experience, if you do this liquid cooling stuff longer. I only had, actually, wait a second. No, I never had liquid cooling in the G5 and in the Mac Pro. So G5, I intentionally didn't have the quad core, the dual socket, and in the Mac Pro, no, the Mac Pro also, the dual Xeon was also air cooled like a 911, like a proper car. So yeah, actually, I think I never quite, let me think. Do I have any of all the freaking gazillion vintage systems. So I think I really didn't have that. Oh darn, this stuff still fails. Oh, I hate this shit so much. What even was this stuff that it did build a build? Oh, always this. Anyways, that isn't the Firefox build stuff, is not the point of today's video. So what also the other problem, I saw some stuff like some Kraken control was actually implemented in µKernel. The problem with this stuff is also, I appreciate that other people have reverse engineered this, like shame on those vendors of not providing open specification and people need to waste their time. I mean, some people have fun, right? Or I mean, when I was young, it was also fun, but in reality, it's like people investing and wasting the time reverse engineering the stuff that recurring theme here should be openly documented. How to, this is like a protocol, right? God darn. You know what we do? Let's look at this in a minute. Something was, it's because the problem with this stuff, as much as I appreciate people reverse engineering this stuff, I'm not the greatest fan of having that implemented in Python. C or Python, both things not super totally amazing. At least give me C++, if not Rust. But so some stuff was in Linux kernel because like to really, the problem is like using this, you have this, it's of course out of the scope of the Linux kernel and you have like some totally non-standard and like only this liquidctl stuff for this one thing. That is, basically I would argue the Linux kernel would need those drivers and then some WinFarm management. Ironically, the Apple stuff, Benjamin Herrenschmidt, IBM PowerPC fame, did some WinFarm stuff exactly for like this G5 I had in the previous video, for like WinFarm in kernel control thing, I think. And we would basically need that for this kind of stuff. I'm not doing that in the Linux kernel, right? But if you are a total fan of C and single address space, monolithic Linux kernel thing stuff, then and you want to have something to do, then there's some liquid cooling stuff that you could implement. But for me, I wonder if, like continuing my microkernel stuff, if I anyway set to do it so that this code can be reused, I wonder if I should implement this in user space as usable for Linux, like basically making the most use of my microkernel experiment of actually implementing that stuff that I actually freaking need for myself, TM. But yeah, leave in the comments below. I think for now, because it totally doesn't scale, right? Like what I do now every week, like for example, today I sit in the office, I'm working and like after 1 hour, I was like, why is this freaking shit so loud? Like, do this bloody fan control stuff, like this stuff. It's idle. I'm like editing my stuff away here, like with 0 CPU load and like some blinking cursor thing here in Emacs and stuff. It's like, I mean, fans 100%, like 30 degrees in the office, thank you very much. It's like just because this fan curve stuff, right? And maybe I implement this like as a workaround for the next weeks, like for some cron job or like maybe not even a cron job, maybe a shell script running, like sleeping a second, and as an experiment and try how satisfied I am before implementing this for real. The problem is that we don't have ambient temperature. It would be cool. I mean, this stuff costs 200. I think the list price for this stuff is like maybe over 200 euro, right? 250 maybe? Something like that. I got it with a discount. Usually, the usual e-retailer stuff for 199 or so, 6 months ago. And for that price, sure, it has some fancy USB control display stuff, but it would be cool to have some ambient temperature. I think it doesn't have an oh darn, I pressed here some, which did I really hate that I introduced that accidentally. The one thing I probably should disable, this key binding stuff. Yeah, so it has liquid temperature. It would be actually cool. I mean, or it didn't reverse engineer, but no, I think it doesn't have that because there's not a cable, not a wire going to the radiator. It would be cool to have a reference ambient temperature, because the problem is for like making the most of this control. Also it is amazing that there are so many reverse engineered drivers in the Linux kernel that I have here even like a gazillion, like dozens of freaking temperatures, right? Even the NVMe drive. The crazy stuff, also that the NVMe drives, they're mostly idle and they get so warm because like, yeah. But the problem is I don't have even a freaking reference ambient temperature. Maybe the closest, maybe I should check with some CPU load. Certainly we can't use the VRM. And even like motherboard with some airflow, maybe that would be the closest of ambient reference temperature we might get to. Also the grippers or something. Can't you somehow use LVM sensors? It has stuff for controlling fans and stuff based on load. Interesting. I didn't. So the problem is I can't directly use it, right? I mean, I was for a test. I mean, LM sensors is two things, right? LM sensors, there are the kernel drivers. So all of those values of this sensors is LM sensors. So all of this stuff, so you see there right now, that comes from kernel drivers. So this LM sensors user space stuff, like this sensor stuff, it's just iterating the directories in sys/this class and fans and stuff. And so these are two parts, and the problem is that this liquid control stuff doesn't have a kernel driver, right? And I'm not going to write this because I have more important stuff to do. Ideally, there should be, as I said some 10 minutes ago. So I think for a test, I prototype. I mean, the best thing is also prototype, right? Protip, prototype, pro, right? Both starts with pro, right? Pro prototyping with a shell script. So what I probably do is, for now, I try my theory as a prototype and like try to find out what is the best ambient temperature to use and base this fan curves off of that, maybe with some load-based boosting for the pump, so that we don't wait for the CPU to get hot but immediately kick off the pump if the CPU load goes high. It is also crazy, in my opinion. Apple has, of course, I mean, even in Apple devices, they have a dozen of sensors. Even they always had, right? Even with a MacBook, like 15 years ago or stuff, probably not the PowerBook. The PowerBook had some sensors. I'm not sure, maybe the PowerBooks had like 4 or like half a dozen. The MacBooks had always many, like at least probably a dozen sensors, right? I think way before PCs. Nowadays, of course, PCs and MacBooks, laptops also have more sensors. It would be amazing though if this would be more standardized. Like if you had, like, not with this, like each vendor is YOLOing some random stuff that they find from their supplier in Asia, so across the street, in Taiwan or Hsinchu or stuff, or Shenzhen. And it would be cool if like you had like on general purpose PCs, you could rely on that there is an ambient air temperature sensor on the motherboard, and not like everyone needs to pick another sensor because like who knows where they are placed and stuff. That would be like, yeah, we have complex stuff, ACPI and so on, but we don't even have a freaking ambient air. But yeah, yeah. So let's. What is also going on with this Firefox? What I've okay, some PIP check current pricing environment. For some crazy reason, this after the last video, it somehow, why does it not build today? And what is it? What does it know? System and crazy stuff. Why did it recently build? Okay, maybe I do that later. Yeah. So what would? So we would want the. So it's. That is crazy, the CPU, and I have no idea how precise, but why is it drawing when it was more idle, or is it not temperature based? I mean, right, we have OBS running. And because before I went live, as it were 3 amps, by the way, just as a reference, at least as far as I remember. Yeah, and I mean, obviously, so before I started live streaming, before I realized now this stuff was running with 100% for like hours until it annoyed me too much, it was still 30 something degree, and so like scaling that from 100% to 30% increased the liquid temperature by 2 degrees. Oh, plus OBS, it was more idle. I was more typing away before that. So yeah. You could even theoretically build in there some AI for like adaptive cooling of like learning the characteristics. If you wouldn't, because the problem is if you like manually tune that, you might need some experimentation and stuff, and theoretically you could of course train this stuff that it's like some simple neural network. It's like, yeah, 2022, because this complexity of cooling, and theoretically you could learn and have some feedback. You could even do this stuff self-learning, like you set a target, like a target, or how would you do that? A max temperature, and I mean, would you even need a neural network? You could probably just use some statistic formula, like some linear math or something, and probably like old-fashioned temperature contour. I mean, yeah. Anyway, it is crazy that few people. I mean, I don't know what other. I really don't know. I mean, most of the people I know don't have liquid cooling stuff. I mean, even if you, so in a more normal setup, you would have just, with like a normal PC, you just, or even, I don't even know, probably even the MacBook stuff, but who knows what complex stuff the SMC is doing, Apple's system management controller. But maybe they also only directly wire that to the CPU temperature. So in a normal classic CPU, PC CPU, air-cooled, you would directly base that off the CPU temperature. The more tricky thing is, which I would want to control the pump more directly, is because the thermal mass of this system is probably much less than, especially because the water, the liquid, gets more hot because there is so little liquid. So instead of like a huge aluminium cooler there, aluminium copper heatsink and heat pipe cooler thing, like I previously had previous videos on Octura NH15 or whatever that was, you have a much higher thermal mass, and these heat pipes do their stuff getting the heat away. So I think with this AIO or other custom liquid loops, you more directly heat up the little water that is over in the CPU block, which is, that is the main reason, the main difference probably why I would want to also drive the pump based off of the CPU load. But anyway, and welcome everyone. Turn, what do we have there? The AI on turn generate more heat, come up with more efficient. Yeah, I mean, it wouldn't like be, I mean, probably even a Pentium from 20 years ago could, like, I mean, you probably only need a neural network like with some 100 cells. Probably even Intel P54 could still do that once a second with like not really increasing the idle load probably. But yeah, it was more of a joke. So how do we do that? I'm a little bit pissed, to be honest, that this doesn't build. This is so crazy. Did say? I know for otherwise a fact that, do I not have this installed? What do I have currently installed? Darn, this yeah, this is not very helpful because it started to build, it updated. Maybe we should actually not update the T2 metadata if the build failed. Things that you realize after. I have 100, which wasn't. I hate this. Oh, did I manage that? Oh, who knows? Maybe. So this built some days ago. So why does the Python stuff fail now? If it fails like this, is nah. theoretically we have some. What do you, by the way, mean with okay, this stuff? You can't mix this stuff up. Why is? And this is also why I don't want this Python like liquid fan control stuff with Python. The crazy stuff is also, I mean, because it's ever failing, breaking Python stuff. The crazy stuff is also another fun or sad story. I had my precious Ryzen overheating the other months because I updated Python and didn't build the bloody liquid control stuff. And so I rebooted eventually, and then on boot up, this liquid control stuff didn't do its liquid control thing because it just errored out with modules, incompatible version stuff. So that is obviously pretty annoying, to be honest. I'm really wondering why we get that now. That is a little bit of crazy one, which is maybe we don't diagnose that stuff now. So for now, what we want to do. The thing is, do we have a CPU load easily? Probably also not. How fast? And some of this Python stuff doesn't build right now. Maybe we do some updates, some other updates that hopefully build better than. This Python stuff. I need to investigate this off camera, not really. Oh, this was not even something important. Did I switch this notifications off now? Because there are always some updates that we could, I think data run today already. Yep, data did something. Also data, our update bot, right? The best invention since sliced bread. By the way, we also probably should update Thunderbird, to be honest. Because it also started to fail too strangely for me. There surely is an update for that, isn't there? I mean, maybe also should use another email client because that's, maybe should we check what would be their version? Maybe we should check the website. Oh, they have some 100 better? Oh no, this is 10. Yeah. Wishful dreaming. Beta. Why do we have that one? Probably. 91.9. That is outdated as of right now. All right, I wanted, what did you mean with Subso? But yeah, welcome everyone. As per usual, you could of course YOLO something into this Python code, but first of all, I never was, I mean, if it would be Lua, I probably would do that, but I'm simply also somehow not a Python fan. I really never, I mean, sure, Python is like a magnitude more amazing than Perl, which is obviously not really a metric, but yeah, you could of course write some Python module, but somehow this is also, I don't really like doing stuff that shouldn't like be done more the right way, and doing that in such a Python way is somehow not the right way. So yeah, for the fan, so we need two things basically. I mean, basically we could re-implement in any language a linear scaling based on the CPU temperature. I think we want to do that for the fan to cool the whole liquid loop, as I said. So that would probably, this T was T control, was that the die or the IO? Value of T control provided to the platform to control the cooling solution, but does not represent the actual temperature of the chip of the processor. Okay, so maximum value is always fixed and unchanged. Normalized 200 for all processors. If you can trust this. Does AMD has? Let's see what's on AMD Reddit. Why is this bringing a... Where is it even? Not here. But it's set here, T control. Can we have this cached? Only recognizes what? What do they mean with AMD only recognizes the new temperature with T control? Yeah, okay, fine, whatever. By the way, if you didn't know, usually these tools, like, you can query on temperature, and can you also, I mean, actually, wait a second, we don't need to use that for that. We can simply, that should be in this class. No, not T. What would that be? Or is it, you know what, things I don't even have a... That was... What? Why is this returning so much? Huh? How did that happen? Do we have... actually expected that to... Oh, there we have that. Ah, HW1, of course. Yeah, thank you very much. That is, of course, not stable, enumerated. Probably we take something like... totally. Probably should be that one, I guess, shouldn't it? Yep, there are probably, let's see. Or is it? Mem junction? Wait a second, critical. I'm also feeling that is not what I was looking. 52. 56. Someone not a Rust fan there. What do you have against Rust? I mean, I'm personally, ironically, I recognize the need for memory safer language, but I mean, I agree that for me personally, Rust is not the best match and stuff, but anyway. Why do you hate it that much? What? Okay, you know what? Yeah. Okay, that is apparently HWMon2, as we see here. Maybe I should have just... Have we been at this one, or have we been... Oh, we have been at HWMon5, right, or not? Oh no, we have been... No, which have we been... Was it not that one? I think it was 5. Where is 5? Or was it... Ah, here we were... Ah, maybe that is... No, whatever that is. Yeah. Ah, yes, RT control. Okay, so apparently we should use that, and so the benefit of using that one is that we simply can, in our prototype script, use this value. We don't need to SED and substitute stuff away there. We directly... Yeah, we probably can get away with using... hello? Oh, right, maybe this column stuff doesn't. So that should be, I mean, even if we use the wrong one, it shouldn't be. We would hope that without major changes to the Linux kernel, it always is temp1 for now, of course, in your real world application. You want then later do that more sophisticated. So 42, is it getting apparently cooler? So just for that, I mean, does it directly if we, I mean, that could change here, so probably we want that. Because what right now I only set one fixed value, and that obviously is not ideal. And for a, so yeah, actually that needs some, let's call this wind farm, just like the Linux kernel for the fun of it. So that would be CPU temp. Was it that one? I always forget the syntax. For testing, let's comment that out and only run that once. Or did I somehow... Message trajectory? What? I did this... so many issues in one copy and pasted line. Actually, wait a second, that doesn't... Did I previously? I think this doesn't... Ah, now it works. Otherwise it doesn't expand. Now you mean sig... Did you also mean... Short period, because you mean... Or you mean super or subscribe? Always abbreviations. By the way, what is the freaking temperature? Total professional. Oh darn, it's approaching 28 degrees in the office. You can't mix this shit up. I need to move for better internet and better temperatures. Yeah, Zig is Zig, right? Zig. Yeah, Zig is indeed one of the better languages. I agree, but anyway, does that stuff build? But with my luck, probably Thunderbird. Let's see. And this will, of course, instantly overheat our precious stuff here. Actually, yeah. So you see a 65. So this, I mean, it goes up pretty quickly, but I mean, we are running liquid control. We are running this pretty fixed. What have I even run this previously? This also doesn't build anymore because what strange. Oh, also someone wanted actually another color for this corrected to be. Just realized that. So what's our temperature now before we? Yeah, I mean it didn't. But also it didn't. It wasn't like 100% loaded, right? This was just single thread load. So yeah. And so the thing is. The pump you don't hear that much. If it's totally quiet, you hear the pump a little bit of this air. It was cooler. It's a little bit like coil whine, like sounding like a little bit coil whine. I would say if you never heard that, like a little bit zipping there along. So what else did we want? We wanted theoretically CPU load, but so for now CPU. Then we need. CPU temp divided by, I think, what do we have there? Is it, we have there, does it make sense? No. Oh, come on. Yeah, it was 28 freaking degrees. So that was CPU temperature. What did we want? So we wanted to control the pump based of that. And yeah, I probably need to make some diagrams. The best is, so truth to be told, I mean, if you go to university and stuff, of course you can model this stuff in like MATLAB and or the GNU substitute, the GNU Octave. By the way, did I recently update that? And so best is always make some simulations, right? It is otherwise pointless. Otherwise, my other recurring pro tip here, don't YOLO stuff together like you see so often, which I also started here, just because I want to hack something, some quick hack now. But otherwise, model this stuff, right? Make a proper model in GNU Octave or stuff, or so, even if it's a spreadsheet, if you have only LibreOffice, but hey, GNU Octave is also free, and think the stuff through, right? Plot there some graphs of the stuff to see, and you see without experimentation, right? If you like plot some temperatures and based off your control values of this, you immediately usually see if this stuff makes somewhat sense or if it's like complete garbage. Otherwise, if you just YOLO this stuff together, then you get random results that you sit there and need to monitor and stuff, and like in hours of basically substituting hours of trial and error with some minutes of modeling stuff. µKernel, where is this? Also, okay, let's do two stuff first. What's going on there? Is this also Python, or what is wrong with this stuff? Now it wants Clang++. What? Somehow we don't have Clang++ for some reason. Why? Don't quite remember doing anything with Clang recently. Always something. So Fen, for this prototyping, it's not ideal. How long? Because this is the next thing. Also, you see I run my default stuff, or immediately goes to 100%. How long does its stuff even run? Because the stuff is even pretty slow, especially if you always use bopens. Like, yeah, I mean, this is totally inefficient, right? You totally don't want to do that. It's total waste of. And this is why the stuff needs to be a little bit more integrated. Obviously, you can't always start all this Python interpretation library stuff. Yeah, so I will prototype something together. I also need to. So this was temperature. So you could. If you could. So ideally, wait a second. Subtract the ambient temperature. Does it make sense? I mean, maybe to, offset your thermal delta that you would have in summer versus winter to have the fans ramping up more for more cooling with less thermal delta. Does that make sense? Which one did we even want to use as ambient? Also, wait a second, this fan gets on my nerves. So I think it probably would work with any temperature, and here you percentage, like if you want right now, like if you have some fan 20% or stuff. And Pumpy will also compute maybe from. Let's do some failsafe. I think you can't even set both in. What do we get now? Yeah, so I guess it always. It's doing something, so this is not like, as you see, based on what is it, 20, so it's like always using some offset as linear interpolation there. I wonder if you can set pump also, set pump speed 27, 25. No, you can only do, I mean, that is really a little bit. Yeah. Ah, wait, you can directly set speed percentage apparently without temperature. If that works for that, oops. Ah, that even works. Okay, but it's a little bit silly that you can't set both. Maybe I should. I just don't want to waste my time. This is kind of stuff like, why did nobody think about that? I mean, this is honestly a little bit silly in my opinion. Especially as this stuff needs to so long to initialize all this Python library stuff and on a 5950X, no less, right? And theoretically, to optimize this, so I would probably only set reset the fan every like 10 seconds. And in general, you could save the previous value and only set this if it changed, just to avoid all this Python overhead and stuff. So yeah, I need to continue to draft something. This can't continue like that. Yeah, so that's basically, so for the, and welcome everyone tuning in, welcome Paul. So for the µKernel, I always said I wanted that to be like Rosetta Stone kind of code documentation stuff, and so that still fits. I always said I would want this stuff like to be reusable for DOS games and demos or other vintage, maybe even like Nintendo, Game Boy, who knows what. Of course, not compiling everything, but like picking like a couple of things, which I'm still thinking, should I do it in C++ or Zig or Rust? Also, again, not the biggest Rust fan. Maybe, unfortunately, lightweight C++ just for the biggest portability, although it's not the best memory safety and stuff, but just to have people the most flexibility to reuse this code for DOS demos or other hobby operating systems. And then starting of writing drivers, as crazy as it is, since of course it makes zero sense otherwise to start your operating system drivers with like fan control stuff, but that is what I just need, right? And I said it's so often people ask me what should you start with. Like I always say, start with what you need, right? And as crazy as it is, I need some liquid cooling temperature stuff. And this Python stuff is for me simply not satisfying. Don't like Python, yeah, and so on. And even if I would be okay-ish with Python, I still wouldn't want to have Python drivers in my operating system, no matter if it's Linux or µKernel. And with the stuff in µKernel, with this stuff in user space, I could potentially use the same stuff on my T2 Linux desktop for my own stuff and µKernel demos. So yeah, that's basically just some summary of like what people do after work when they're like, it's crazy that I mean, sure, the people with 2% market share and then only total nerds and enthusiasts running liquid cooling stuff. But anyway, it's somehow crazy that, I mean, at least we have something, but it's also on the other hand that it's not like, I mean, this command line parsing that you can't set two things at once. Why is it? It sounds like the easiest thing. I mean, maybe you can somehow, but it's not immediately obvious to me. Maybe some other separator, but I think not. I mean, theoretically, they could stop parsing at numbers and continue. I mean, even in my own command line stuff, in exact image and my own Lua stuff, like we have very sophisticated and PDF library in Lua, and even there for our debug and testing stuff in Lua we have like in Lua for our testing stuff more sophisticated command line parsing, like PDF open and extract page and stuff. It's like, it's not so hard to do. I mean, even in my 15-year-old exact image open source stuff in C++, we have exact image, econvert, input, filters like ImageMagick and stuff. It's like, anyway. Yeah, that's probably that for this video here, one hour at a time. Yeah, so when Amazing OS, did I put already the other day? Actually, the other day I unpacked an RISC-V CPU the other day without MMU, I think. Super cheap though, like less than, I think actually like less than $10 per CPU, 180 megahertz or so, up to the ESP32. Maybe we do something with that. And this is with our OS stuff, like starting with stuff I need today, certainly. And I'm totally aware I'm not writing a desktop. There's not even the year of the Linux desktop, and I'm obviously not writing in a µKernel in 1 year. So starting with stuff I need, and then we see also like growing the stuff. The idea would also be having fun with vintage stuff. I auctioned freaking NVIDIA and NV1 and other cool stuff. What other cool stuff? NVIDIA NV1. I think I got some other stuff that I probably forgot. So, and in general, other like 3D demos, just for education and also fun, right? This new hobby of people of having fun with vintage and retro stuff and learning stuff and showing how this. Why? Because it's way easier with this vintage hardware that was very simpler, where a single man like Linus Torvalds, a single human, could start his hobby OS from scratch. And like nowadays, even writing an AMD GPU driver is like a 10-year job for a team of stuff. Anyway, so yeah. I probably YOLO some stuff here together for this to work a little bit. It's probably pointless to do on stream. As per usual, leave in the comments below what are your thoughts there. Did you have any liquid cooling, fan control stuff? Did you bother do stuff with such things? And as usual, hope you learned something. Would be amazing if you subscribe, and otherwise see you soon for all this fun stuff to come. And I have some Firefox Python stuff to take a look at as well.